So this is just to review so that we get all the vocabulary that we need for Unit 7. Just pretend it's not there, guys. It's fine. Okay, so this is the homework that you had. Here's the vocabulary. Polyhedron. That covers anything that's three-dimensional and has polygons as its faces. So like a cylinder and a sphere and a cone would not be a polyhedron. Anything circular or curved is not considered a polyhedron because circles are not polygons. On a polyhedron, there are edges. The edge is where two faces come together. Think about if you were standing up here, you were walking closer. Don't fall off the edge. Right, that's the edge. That's the edge right there. All right. Faces are the flat surfaces. That's a face. These are faces. Everything, all of the sides are considered faces. Vertices are where three sides come together, so it's going to be a point. Okay. We talked about planes way in the beginning of the year, and a plane is an endless flat surface. So all of these faces are part of a plane. So in other words, if you extended these in every direction, they would be part of a plane. So each face you could kind of consider as sort of a piece of a plane, endless flat surface. Okay, so coplanar is when two or more things can be contained in the same plane. Again, we talked about that way in Unit 1. If two things can be contained in the same plane, then they're considered coplanar. So for example, this edge and this edge are in the same plane. They are coplanar because the side, or the face, this face contains both those edges. So those are considered coplanar. But what about this face, this edge and this edge? Can they be contained in the same plane? Could I get one flat surface to contain both of those? No. So those are considered, this word, skew. Skew lines, which we've learned before, but you might need to be reminded. Skew lines are two lines or segments that never intersect, but are not parallel. So usually you're used to two things being parallel and they never intersect, but now if we make it so that they are not in the same plane, then they are considered skew. Okay? All right, so you guys filled out some of this for your homework. I'm just going to scroll through so that you can kind of see the answers and see how you did. We'll talk about some of the things that might have been confusing. When you're counting vertices, you got to make sure you count each one once. But if you think about like the two bases, you could just count the corners of those. You don't want to count them twice. So this would just have 8 vertices. And then the 12 edges, because there's 4 edges on the top and 4 edges on the bottom, and then there's 4 connecting them. So that makes 12. And there's 6 faces, because there's 2 bases, and since both of those 2 bases have 4 sides, there's got to be 4 more faces that you add to connect them. This is called a pyramid, this one here. What's the difference between a pyramid and a prism? Here, let me get a better diagram to look at. Right? These are all prisms. And this one is a pyramid. What's the difference? Yep. So if they won't be able to see this in the video, but if I hold up these two things, they have the exact same base. What's different? Okay, good. Try pyramids. The faces that are not the bases are triangles. Okay. There's another one down here, right? Triangles as faces. And prisms have rectangular faces. The faces that are not bases are rectangles. Okay, how many bases does a prism have? How many bases does a prism have? Here's a prism, here's a prism, here's a prism. How many bases are there? Two. Two bases. It's like there's a top and a bottom. And with a pyramid, there's only one base, and then it comes to a point. Okay, so today we're going to be talking about things with two bases. Okay, so let's define prism. This is a really important definition. A prism is a polyhedron with two congruent parallel faces. Two congruent parallel faces called bases. That's what makes a prism a prism. Okay? And a prism is named by the shape of its base. So this is a pentagonal prism because its base is a pentagon. This is triangular, rectangular, pentagonal, hexagonal. Whatever shape the base is, that's how you name the prism. And this right here, another important message. Base does not mean bottom. Even if, look at this, see that rectangular prism? It's laying flat on a rectangular side, but that doesn't make it the bottom, it is bottom, but it doesn't make it the base of the pentagonal prism. This base is still the two pentagons. Those are the bases, not what it's sitting on. Base does not mean bottom. Really, really, really important to remember that, okay? So, if what I said is true, and base does not mean bottom, if I define height as the distance between the two bases, then where's the height in this? Oops, that's not working. Where's the height in this pentagonal prism? Where's the height? Want to come draw it? Where's the height? Yep. This is the height. Think about your height. However tall you are, you're 6 feet tall. If you lay down on the floor, should I now measure you from the floor up to however high your body goes? If I asked you your height when you're laying down, are you still 6 feet tall? Yeah, you just happen to be on your side, right? You would still call your height 6 feet. It's the same thing with this pentagonal prism. It happens to be laying down, but the height is still the distance between the two bases. It's like your height is the distance from your feet to the top of your head, right? Feet to top of head. That's the height. Okay? Again, another very important message there. Okay, so altitude and height are kind of the same thing. Altitude is the segment you can draw, it has to be perpendicular. Most of the prisms we're going to be dealing with are going to be standing straight up anyway, so the height will be one of the edges. But there is such thing as an oblique prism, which is kind of tilting to the side. And the height would still be dropped down outside of the prism, just like we did with two-dimensional shapes, right? Has to be perpendicular. All right, so cylinders, same idea. Everything I just said is true about cylinders. Different category because the bases are not polygons, they're circles. But there's still two bases, and the height is still the distance between those two bases. And base still does not mean bottom, okay? Okay, in this chart, you might have noticed that the two columns here, this column and this column, all the way through, same numbers, right? Because the number of edges on the base has to be the same as the number of faces that are not bases. Let's look at the pentagon. Let's look at the pentagon, for example. The pentagonal prism. Right? There are 1, 2, 3, 4, 5, 6 sides on each base. 1, 2, 3, 4, 5, 6. So there has to be a face that connects the two parallel sides. So it makes sense that if there's 6 sides on the base, then there's going to be 6 faces that come off of those 6 sides. So these two numbers should be the same in that whole column. All right, and then identifying the polyhedrons. There's the answers there. Remember, base does not mean bottom, so when you look at F, the base is a pentagon because there are 2 pentagons that are congruent and parallel. That makes them the bases. So it's a trapezoidal prism. Base does not mean bottom. All right, and there's the edges and faces, etc. Vertices are just the points. So you're going to count, there's 5 points on this base and 5 points on that base. There has to be 10 vertices. Bless you. Okay, so moving on, we are going to start these notes here. Okay, so surface area and volume of prisms and cylinders. I know this says continued. This is continued from the pre-lesson we just did. But they're also, sometimes we do this with a more elaborate notes sheet in between. It's going to be very important that you pay attention to our conversation today, because this notes sheet that I'm giving you is the simplified version. It's the no frills version of surface area and volume notes. Okay, so what we talk about and elaborate on, you might want to jot down, a few notes for yourself along the edges so that you remember the key things about using these formulas. Okay? All right, so volume you've done before. Volume is just how much space is inside of a solid, three-dimensional object, right? So it's how much you could fill, like if you were going to fill it up with water or fill it up with sand, how much can fit in there. Surface area is basically going to be the area of all of the faces added together. So, if we look at a three-dimensional object, and we imagine that it's flattened out into a pattern like this. This, by the way, is called a net. If you take a pattern like this, this will fold into a triangular prism, like this. Oops, wrong way, like this. Okay. The surface area is just the area of all these faces added together. So on your last test, we did some two-dimensional figures that were odd shaped, like it was a rectangle and a triangle put together. Remember doing that? Okay, so to find the total area, you had to sort of split it into sections, find the area of each section, and add it together. That's pretty much what surface area is. Okay, surface area is taking all of the faces and adding them together. Now, we have a formula for doing that. It makes it a little bit simpler. The base of a prism, just like we defined with prism, right? There's two congruent parallel bases. Those are the only two things that you could call the base. Right? And identifying that base is going to be so key to everything we do today. All right, in the base of a cylinder, same thing, they just happen to be circles. Okay, so finding the volume of a prism. The formula is capital B, capital H. Now, it's important to distinguish between what we use as the capital B and what we've used in the past as a lowercase b. And a capital H versus a lowercase h. So, if we found the area of a rectangle, just a plain old rectangle, two-dimensional thing like we did in our last unit, the area was BH, lowercase b, lowercase h, right? That was just the length of a side times the length of the other side. Here, we're talking about a capital B, so we don't want to say capital B stands for just base. Capital B stands for the area of the base. That's really important. You might want to copy what I copied here. Area of the base is your capital B. Okay? And your capital H is the height of the whole prism, which we just defined as the distance between the two bases. Once you've identified those two things to get the volume, it's just area of that base times the height. Now, if you could picture this, if I could put little boxes along the whole bottom, right, so that there's little cubes in here, that is going to be a measurement of volume. Cubic units. How many cubes can we fit inside this three-dimensional object? So if I have 4 cubes fit along the side here, and 4 cubes fit the other way, then how many cubes fit on that first layer if it's 4 by 4? 16, right? Which is just the area of the base, right? 4 by 4, it would give us 16. So that's how many cubes we could fit on that first layer. Now, if I want to know how many cubes fill up the entire thing, what piece of information do you need? What's the height? Exactly. How many layers are there? If there's 16 cubes that fit in one layer, how many layers are there? Then you just multiply and you'll get how many cubes could fill the whole entire thing. This, by the way, is a very good strategy if you're guessing how many jelly beans in a jar. Did you ever do that? Right? Little contest. How many things are in the jar? Count how many are on the bottom. Count how many fit up the side. Multiply. You're going to get a really good estimate of how many jelly beans are in that jar. Volume. Okay. Unfortunately, jelly beans are very strangely shaped, so it doesn't always work out the way you want it to. But it's just a strategy. Okay, same exact formula for cylinders. Capital BH, area of the base times the height. Now, that looks like a very simple, nice formula. Easy. Area of the base times the height. No problem. Here's the trouble with this. The trouble is this B is loaded. It's a loaded B because it stands for so many different things. What if the base is a triangle? How do you find the area of the triangle? 1/2 base times height. What if the base is a regular hexagon? What's the area for that? For that one? 1/2 AP, apothem times perimeter. Remember that? Okay. What if the base is a trapezoid? Area is... Here they are, all on the board here, right? They are also on that pink sheet that I just gave you. So that's why it's really important that you keep track of that formula sheet that I gave you, because this capital B stands for the area of whatever shape your base is. And there's lots of different formulas that could need to be applied there, including cylinder. Area of a circle is pi r squared. Okay? Okay, surface area of a prism. Like I said, it's just taking the area of the sides, all the faces, and adding them together. Now, we do have a formula to streamline this process. You are going to have to find the area of each of the bases, so you just need the area of one of them, and then double it, because we said that the bases had to be congruent, correct? Right? So just find the area of one base, multiply by 2, because there's 2 of them. But then what's left? What's left is this big rectangle here. And that big rectangle, to find the area of a rectangle, what do we do? How do we find the area of a rectangle? Base times height. So this base times this height. Now, this rectangle, is the height of this rectangle the same as the capital H height of the whole prism? Distance between the two bases. Yeah, is this the distance between the two bases? Yeah, it is. Here's the two bases. Distance between, so capital H is going to work as the height of the whole prism, but it also works as the height of that rectangle that we're trying to find the area of. Okay, the base of this rectangle, this length right here, if we look at this net here, the length of this rectangle wraps around the base. So what could we use as the length of that rectangle if it's the distance around that base? It's the perimeter of the base. Look at this one. The rectangle, this length, see how it wraps right around the base? You guys see that? That's the distance around this shape, and the distance around a shape is the perimeter. So the area of this whole rectangle is the perimeter times the height. Base times height. So perimeter times height. So if you see this formula here, surface area of a prism is just pH plus 2 times the area of the base. Because there's two bases. So this piece gives you the area of the rectangle. Okay, now with a cylinder, it might surprise you, but when you unwrap a cylinder and draw the net of a cylinder, is there still a rectangle there? Yep. So there's one rectangle and two circles if I draw the net of a cylinder like this. So we still need the area of the rectangle, that's this, and then the area of the two circles, the two bases. So perimeter of a circle is not called perimeter, it's called distance around a circle is called the circumference, right? So instead of pH plus 2b, we have CH plus 2b. It's the same thing, circumference times the height instead of perimeter times height. But it really is the same idea. Now, as a reminder, circumference is 2 pi r. So if we plug in 2 pi r for our C, we get 2 pi rh. And area of a circle is pi r squared. So if we plug that in here, we get 2 pi r squared. So you might see this formula as a surface area of a cylinder. Okay, so this just lists out the steps for finding surface area and volume of prisms and cylinders. Okay, we're going to do one together, but there's where you can go to find the list. Something I want to point out before we do one. Step 1, important. You need to identify what shape you're looking at, because everything we do in these formulas relies on the fact that you've identified the right base. Okay, and the prism's named for the base. So I'll show you that in a second as an example. This is a requirement, not a suggestion. When I ask you to find volume or surface area on homework, test, quiz, formative, doesn't matter what, this list is required. Capital B, area of the base. This is where whatever formula goes with the shape that is the shape of the base. Right? You got to use the appropriate formula. Height is the distance between the two bases, and the perimeter is the perimeter of the base. You have to show those three values separately, listed like this. Okay? That serves two purposes. First of all, you'll make less mistakes. Second of all, if you do make a mistake, we can find exactly where your mistake is. Okay? Which is super important if you ever want to get partial credit on tests. Okay. I'm actually going to skip down to doing this one together with you. So, what is the shape of the base of this prism? Not a square. A triangle. What did I say about the base? The base is not the bottom. Base does not mean bottom. Sometimes it's the bottom, sometimes it's not, but it does not mean bottom. Base is the two congruent parallel faces that are connected by rectangles. So this on the bottom is not the base because there's not another one here connecting it. That is not the base. The base is actually the front and the back of this prism. Those are the bases. Do you see how important it is to identify the base? All of your list and formula is going to be wrong if you've got the wrong base. Super important to identify the base correctly. Okay, so the base is a rectangle, so we're going to call, I'm sorry, the base is a triangle. After all that, I said the wrong word. The base is a triangle, so we're going to name this a triangular prism. Now, everything has to do with the base. So, when we make our list of capital B, this is going to be area of the triangle. Which is 1/2 BH. Capital H is the distance between the two bases. Let's look at that one on this diagram. What is the distance between the two bases? What number represents the distance between the two bases? 5, right. The height is here. That might seem weird. The height is there. But like I said, this is just kind of like it's laying down. So the height, capital H, is 5. And then P, the perimeter of, again, the triangle. What 3 numbers do I have to add together to get the perimeter? Distance around this triangle. Good. 6 plus 8 plus 10. This happens to be a right triangle. Did I have to give you all 3 sides? Or could I have given you 2? And then what could you have done to get the third one? Pythagorean theorem, right? Okay, so 6 plus 8 plus 10 is 24. Height is 5, we said. We need to still figure out the area of the base. Triangle is 1/2 base times height. So we need the base and height of this triangle, which have to be perpendicular to each other. So in this case, the 2 legs serve as the base and height of the triangle. So 1/2 6 times 8 happens to also be 24. So we have those 3 values now. Capital B, capital H, and capital P. We're going to plug into our surface area formula. Surface area is PH plus 2B. We have our values now. Perimeter is 24. Height, H, is 5, so that's the PH, plus 2 times area of the base is 24. 24 times 5 is 120. 2 times 24 is 48. Add these, you got to do those separately, right? And then add them together is 168. So our surface area is 168. Since it's area, it's square meters. Volume is capital BH. Again, all we have to do is pull from our list now. Our capital B and our H. Capital B is 24. H is 5. That's 120. So our volume, 120. And since it's volume, it's cubic meters. Okay, so this is a cylinder. With the list for a cylinder, we're going to have the same components, even though we only have 2 things labeled here, right? We just have 11 and 7, so there's really less on a cylinder to have to deal with, but the list is the same. Capital B for area of the base, capital H for height of the entire cylinder. Remember, P equivalent in circles is going to be C for circumference. So instead of BHP, we have BHC for circumference. Now, area of the base of a cylinder is a circle, so how do we find the area of a circle? Pi r squared. So if radius is 7, we're going to do pi times 7 squared, which is 49 pi. So 49 pi is the exact answer. Remember, if you're asked to leave your answers in exact form, then you want to leave it with pi in your answer. If we change this to a decimal, you could put 49 times the pi button in your calculator and get a decimal. But it's good to keep it exact till the end anyway. All right, the height. What is the height of this cylinder? 11. I know it doesn't look like it's the height, but remember what we said. Even if you're laying down, your height is still the same. It's the distance between the two bases. So the distance between the two circles is 11. Circumference is 2 pi r. So 2 times pi times 7, 14 pi. So surface area, again, we're going to have CH plus 2B. C is 14 pi. H is 11. Plus 2 times area of the base is 49 pi. 14 times 11, 154 pi. Plus 2 times 49, 98 pi. Add those together because they both have pi in their answer here. So 154 plus 98 is 252. Pi. Now, since it's area, again, we're going to have square meters. That would be the exact form. If we wanted an approximate form, this is going to be 252 times pi. And it's 791.7, approximately. That's the approximate answer. All right, volume. Again, capital BH, area of the base times the height. So we're just going to pull from our list here. Area of the base is 49 pi. Height is 11. Multiply 49 times 11, and you get 539 pi. Oops. We need to put our units here. So cubic meters for volume. And that's going to be approximately equal to 1693.3. That's the approximate answer.